Ray Munir, and I'm doing my presentation on the physics behind martial arts. I have been doing martial arts for 8 years, and I am currently a black belt in Taekwondo, Jiu-Jitsu, and Muay Thai. There lies many fundamental physics principles behind martial arts, but first off, let me give you a brief history. Although the earliest evidence of martial arts goes back a millennia, the true roots are difficult to reconstruct. One of the earliest practiced martial arts in history is Shaolin Kung Fu. Shaolin Kung Fu is a series of fighting styles which have been developed over a long historical period in China. In order to survive in an extremely hostile environment, Chinese civilians developed primary means of defense and attack that included leaping, tumbling, and kicking. Although they knew how to fight with rudimentary weapons made from stones and wood, fighting with bare hands and fists became essential skills. The martial arts we recognize today as Kung Fu had their origins in the Shang and Zhou dynasties, ranging from 256 BC to the 17th century. During the following Qin and Han dynasties, wrestling and swordplay became well developed and were popular among civilians and troops. Now, Kung Fu is a widely practiced martial arts, although not quite as popular as its main rival, Taekwondo. The ancestral roots of Taekwondo began 2,300 years ago in Korea. Tai means to kick, Kwan means to punch, and Do means the way or the method. Like any sport, martial arts is governed by the rules of physics. Every kick, punch, jab, or headbutt that you throw is somehow related to physics. The principles of force, momentum, kinetic energy, and inertia are all applicable to Taekwondo and Kung Fu. First off, force. The most basic move in martial arts is throwing a punch or a kick. In doing so, you are generating force. The equation for force is equal to mass times acceleration. Going more in depth, the equation is mass times velocity over time, where both mass and acceleration are directly related to force. Thus, if you increase either or both of these factors, the overall force will increase, and vice versa. Taking all of this into consideration, who punches harder, a large person or a small person? Well, the large person has bigger muscles and more mass, but requires more muscle power to move the greater mass, so the acceleration of the punch is reduced. However, the smaller person has smaller muscles and less mass, but the acceleration of the punch is much greater. Thus, the striking force of the two punches may actually be equal. A larger person has more reach, more mass to absorb blows, and more strength. The farther a punch travels, the more time it has to accelerate, so a larger person with longer arms may actually be able to generate more power. However, it takes more time to cover the long distance, which may give the smaller person time to avoid or block the punch. The most important body part in martial arts is the hip, because it is the power source of all attacks and defenses. Using the force equation, we know that increasing the mass involved will increase the force exerted. This is done by utilizing our hip in the strike, because it will help involve more of your body, which will increase more of the overall mass, and which will in turn increase force. This is especially important when doing more advanced moves, such as roundhouse or back roundhouse kicks. Related to force, attacking an opponent also generates momentum. The equation for momentum is P is equal to mass times velocity. There are two types of momentum, elastic and inelastic momentum. Elastic momentum occurs when two objects are headed towards each other and, after the collision, both objects are moving opposite of their initial directions. Momentum and kinetic energy are both conserved in this scenario since the two objects are bouncing off each other, therefore transferring kinetic energy. An example of this is when you clash bow staffs with another fighter. The bow staffs initially move towards each other, but then they collide and move opposite directions. Another type of momentum is perfectly inelastic momentum, which is when a moving object hits another object that is initially at rest, and after the collision, both objects move in the same direction as the initial object, but at a slower velocity. In this scenario, momentum is conserved, but kinetic energy is not conserved, because both objects are sticking together and they are moving in the same direction at a slower velocity. An example of this is when you tackle somebody to the ground. You guys are both moving in the same direction, although at a slower velocity. Another concept related to martial arts is kinetic energy. As we punch and kick, our hands and feet are generating vast amounts of kinetic energy. The equation for kinetic energy is 1/2 mass times velocity squared. Similar to the force equation, manipulating the mass and velocity of a punch or kick will change the amount of kinetic energy produced. As a punch or kick reaches its target, all of its kinetic energy is then being transferred into the recipient. If a person stands still, his body is not producing any kinetic energy. Kicking in particular is a great example of Newton's first law of motion. An object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Inertia keeps our own body still. In order to perform a powerful kick, one must first expend enough energy to overcome the inertia to make it move. Similarly, it is difficult to stop a kick or a punch mid-flight due to the massive amount of inertia that want to keep our leg in a fixed path. Therefore, we must expend a lot of energy in order to make it stop. That's all, guys. Thanks for watching. I really hope you guys enjoyed.
Everybody was kung fu fighting. Those kids were fast as lightning. In fact, it was a little bit frightening, but they fought